question using Q&A window. We'll take questions at the end of the talk. We'll try to address as many questions as possible, but we will be limited by the time of 60 minutes allocated to this webinar. Since this is an ACM initiative, it's only fair that we spend a few minutes to understand what ACM India is all about. They are at a glance on this slide, but let me give you some examples of what being member of ACM means. You will be part of the world's largest computing society. Out of the 1 lakh members worldwide, about 10% of them are from India and half of them are students. Since majority audience is students, let me highlight some student activities from this slide. ACM India is spread across the country mainly due to its chapters. We have 20 professional chapters and 230 student chapters across the country. As a chapter, you get access to ACM's Distinguished Speaker Program and ACM India's Eminent Speaker Program. You can invite any expert for any of the time. We also have Best Student Chapter Award, which is a recognition of activities done by as a cash prize. ACM India organizes summer and winter schools for students in different research areas in computer science. Faculty for these schools is drawn from prominent academic institutes and industry. Unfortunately, we had to cancel this year's summer schools, but we are hopeful to have them in the winter. The special interest groups or SIGs in India organize national level conferences like CORS, COMAD and IC. We have student scholarship program to attend these conferences. We have something special for girl students. ACMW, which works for empowering women in computing, have many initiatives for girl students. We have Lady Ada programming competition and hackathon for girl students. We also have one summer school exclusively for girl students. We partner with Anita Borg Institute for Grace Offer Celebrations India, the largest gathering of women professionals. We offer scholarship to 40 girl students to attend this particular event. Now it's my honor and privilege to introduce our today's speaker, Dr. Naveen Kamra. Naveen did his BTech from IIT Bombay and PhD from University of Wisconsin. He is currently co-founder and CTO of RallyScore.com, a startup on helping companies to filter job candidates based on evaluation of actual job-related skills. He is very active in Pune's technical tech community and one of the creators of PuneTech.com, a portal for tech community in Pune. He has previously worked in many companies, large and small, in India and USA, and have played many roles, right from developer, architect, manager, and now CTO. He is on the advisor of many companies, including Government of India initiatives in the innovation and incubation space. Let me welcome Naveen and his handover to Naveen.
All right. Thank you, Shekhar, for that introduction. Hello, everybody. I am going to talk about a very simple topic. Okay, it is going to be the common mistakes that students make during campus tests and the first interview. I'm going to focus mainly on technical questions, not about more general issues. The other thing is that this talk is not going to be a very hi-fi talk. There is not going to be any complicated algorithms or advanced topic in computer science. It is all going to be very simple things. But before I start, I want to give you an idea of why you should listen to me. Where is the source of my knowledge coming from? As Shekhar mentioned, I have spent a long time in the industry. I have worked for large companies and small companies. I have worked in the US and I have worked in India. I have been hiring people for a long time, but more specifically in the last 7-8 years, I have been running a company where we create campus tests for our customers, and This is all based on, hundreds of colleges in India, hundreds of companies, and over the years, I have seen a lot of patterns. Okay, so based on the patterns I am seeing, I'm going to give you my views on what are the common mistakes. Now, the other thing I want to make sure you understand is that this is not about the really fancy problems that Facebook and Google ask, right? I mean, that gets a lot of media attention. Everybody talks about those, but really that is not the bread and butter of the industry, right? When Facebook and Google are hiring a tiny number of superstars and giving them like a 1 crore salary, they are doing it for the effect. They are doing it so that they can get headlines in the newspapers. But even they and most other companies, the bulk of the hiring is done on the basis of much simpler roles, and nobody is expecting you to solve really complicated algorithms during your job, right? So I want to talk about the more basic, simple day-to-day things that are needed on the job and which also get asked in interviews, right? So, this talk is about simple things, not very complicated things. Okay, and to prepare for this talk, what I did was I put up a very simple sample test, and a number of you, from the students who have joined this talk today, some of you attempted that test, and I analyzed the results, and I am going to share my views on the basis of that test, right? And I will first talk about the results and then I will go into the detail. The test consisted of three major sections. One was a simple programming questions. The second was some SQL queries, and then third was objective questions based on just general computer science background knowledge, right? And before we go into the details, let's take an overall look at the test results. Okay, now this graph that you see on the screen is the results of all the people who took the test just for this talk. The red line you see, that is the typical cutoff. So anybody scoring below the red line is going to get rejected and will not even get called for an interview. And obviously, all of you who appeared for the test, you are not even, many of you are not fourth year students, and since this is not a real job interview, so some of you took it lightly. So that kind of explains why so many people have scored below the cutoff. But let me tell you that next year or whenever in your fourth year, when real camp reviews are going on and when real jobs are on the line, the performance is similar. This graph is the same graph I see when companies go for real campus tests, right? So these examples, although I have taken examples from your submissions, keep in mind that these are typical, and I have been seeing the same thing for the last 7-8 years. Okay, let's look at the section-wise performance, right? So for each section on this slide that has shown up, I am showing the percentage of the submissions who got roughly passing marks in that particular section. And you can see that, and again, even in real campus tests, the percentages that I see are exactly the same, just a little plus or minus a few percent, but otherwise, this is the overall trend. In programming, less than 1/5 of the students are able to get even a passing score. Forget a good score. In SQL, I picked slightly more advanced questions for SQL, and the passing score was pretty bad. Data structures and algorithms, the score is fairly decent. 40% of the students did reasonably well, but I will get into some details of why that doesn't quite work in the actual interview, right? You do reasonably well in the objective questions, but in the interview there is a problem. Threads and synchronization. Now, this is one of the areas in which companies like to ask questions, because this is a thing that is important in real life, and it causes real and serious and hard to find bugs in real life. And it is a topic that is taught pretty badly in colleges. And obviously you can see that the performance in threads and synchronization is pretty bad. And I just picked one specific set of questions related to hash tables and hash functions. The reason is because hash tables are very, very important in real life, right? All the other fancy data structures that you learn, red-black trees and AVL trees and skip list and God knows what all they teach you. Hash table is used more than all the other data structures combined. And these questions prove that practical application of hash tables is still a problem for most students, right? So this is the overall picture, and what I'm trying to point out is that unless you improve your preparation for the campus tests, which you are going to have to take next year or 2 years from now, depending on which year you're in, you people are going to do badly, right? So that is why I am going to get into details of each of these sections. I will get into the details of what are the kinds of mistakes you make and what you can do to improve your preparation for it, okay? So let's start with programming, right? What are some of the common problems in programming? The biggest issue is that computer science and IT graduates with 4 years worth of studies and with fairly decent scores like 60% plus, 55% plus in their 4 years are to write working programs. Okay. Now, I'm not entirely sure of why this happens, but I'm guessing it is because many of you are able to get marks in your practicals in college just based on, if the program kind of looks okay, then you get marks and partial marks and things like that. There are other problems also, which I will cover. But basically, this is just one example I picked out of the submissions I got over the weekend. You can see that this is supposed to be C++ code, but a capital F in the for, a capital U in the using. This is not legal C++ code, right? So whoever wrote this has never actually compiled C++ code in a compiler, because they would know that this is just not going to compile. And the system complained. The system complained that there is a compiler error on this line and that line, and still, if you are not able to figure it out, if you are not able to read compiler errors and fix them, right, then that's a problem, because that is one of the most important things that companies are looking for. Okay, so you need to be able to write code which compiles cleanly, right? Which there are no compilation errors. You need to be good at reading the output of the compiler and then using that to fix your program. Okay. Another problem is that so many students, even in this particular test, so many students just skipped the programming part. They just wanted to see what is there the rest of the test and so on, right? Again, I understand that all of you were not appearing for a real test, and that is why you might have skipped the program. But when there is a real campus test and when there is a real job on the line, still a very large fraction of students just skip the programming part. I don't know what they're thinking. They're thinking maybe, well, programming is optional and I can get by just on the basis of the multiple choice questions. But that is not true. Most companies are not hiring you to answer multiple choice questions once they join, right? They're hiring you to write programs. So if you just skip the programming question, the chances of you getting called for an interview go down drastically. So people skipping programs, that's like the biggest mistake you can make. Okay. Now, another problem is that, people tend to hard code. Their programs, and there are this is another example of how if you have never written a program, there is you make mistakes which are obvious to anyone who's written programs regularly. If you can see the marked part here, right, I less than or equal to 10, this is going to go past the end of the array. If you have written any array-related code in C, you should know that the for loop has to be I less than the length of the array, not less than or equal to. This is going to cause problems which are, difficult to figure out what is going on. It'll just work and crash or do something very weird. Similarly, by hard coding, what I mean is that the program contains very specific things of the specific problem that was asked. And if you change anything in the problem, anything in the input, the program stops working, right? So here is an example from a different program where the for loop, the number 5 is hard-coded in the for loop. So this is just, it so happened that the example given in the program contained 5 inputs. And that is, the person wrote a program which works for 5 inputs. If I make it 4 inputs, this program will stop working. If I make it 10 inputs, this program will stop working, right? This is the kind of program that is just not acceptable in industry. It is only acceptable in college practicals. And you need to learn to write programs where there is no hard coding. Similarly, there is a different kind of hard coding, which is the correct algorithm which produces the output. What happens with many students is that they just change the program, do whatever weird code needed to write just to somehow make that output come out. Okay, so in this particular case, I didn't even understand what this code is supposed to be doing. It is doing something that has no relation to the question that was asked, but somehow it is producing the output that was given in the example. Now the thing is that the program you are writing, the company isn't looking to see if you can produce the same output. The company is looking to see whether you can implement the algorithm and whether you can solve the problem, right? So somehow or the other, producing the same correct output by hook and by crook is not what is expected from in the test. Okay. One more thing, copying. Okay, now let's just take the example of this particular test. Like I've kept repeating that this test wasn't for any real job interview. Nobody is going to get anything out of this test other than some knowledge of the kind of questions asked in campus tests. And yet in this test, there were a number of students who cheated. Okay. And by cheating, what I meant is that they copied programs from each other and then pasted. And you know what? Companies are not idiots. Okay. When you copy, they can tell. Some companies you can fool. But then again, if a company cannot tell that you are cheating, maybe you shouldn't be joining that company. The company contains incompetent people. But a company which has competent people will figure out that you are cheating. Okay. And then in a lot of companies is much worse than not knowing anything, right? Cheating means that you are dishonest, and the company doesn't want to hire dishonest people. So a lot of companies I know, if they detect cheating, then you are rejected on the spot without any other consideration. No matter how much you have scored elsewhere, no matter how good your marks are and so on, if you have cheated, you're rejected. And this is quite common. And like I said, companies are not idiots. So if you are copying, the intention is to see how you write code, and then later on in the actual interviews, you are going to be asked questions about the program. Most of the people who cheat, even after cheating, their programs are still wrong. That is one problem. And the second problem is that in the interview, they will not be able to answer questions about that program. So it is ultimately not going to work out. Far better to actually learn to program and write correct code yourself, right? There are two kinds of cheating that happen. Cheating from friends happens and cheating from internet happens. And both of them are easily detected by the company, okay? So just avoid that. Now, all of these were problems where people were unable to write working programs. Okay. Now let us move on to the slightly better candidates where they are able to submit a working program, but still there are problems. Okay. Before that, I go there, I'm seeing some questions saying that, okay, if the logic of the algorithm is correct, then what is the problem? Why are you so stuck up on the syntax? If I write a program and I give it to a customer and the program doesn't work, the customer does not care whether the logic is correct or not, right? The customer is paying for a working program. So, this whole thing about if the logic is correct, then the syntax doesn't matter. That is useful in the old days ago when you used to write programs on paper and you couldn't check the syntax, and that is why we would say, okay, fine, if you understand when you are at a computer, you can write working code. But these days, all of you are sitting at a computer, you have access to a compiler, the compiler is giving you error messages, and if you still can't write working code, then I don't care whether your logic and algorithm is correct. I mean, you can't write a working program, I can't hire you, right? It is that simple. So now moving on to solving, candidate has written a working program, but there's still a problem. It is amazing that the number of candidates who don't read the question properly, right? They just skim through the question, they decide in their mind that, oh, this question is supposed to be doing XYZ, and they write a program for XYZ, right? They spend 1 minute reading the question, they spend 30 minutes writing the program, and they have written a wrong program because they didn't read the question carefully, or they read the question but they didn't understand it and they didn't study. If there is an example given in the question, most companies will give you an example of, for this input there should be this output. So if there is an example given, they don't study the example, they don't understand what is going on, and so you just completely wasted your time because you wrote a program that does something completely different from what, not completely, but different from what was asked for. And again, this attention to detail is one of the most important things in an employee, right? If a manager has to keep checking whether you wrote the correct program or not, then you're a good employee, right? Once I have given you, as a manager, if I have given you a program to write, I want you to write a correct working program for exactly the requirements, not something that I have to double check. Then why do I need you? I would write the program myself. So reading the question carefully. So I will give you an example. Okay. So suppose I ask a question. It says count the words in the input. And the second part of the question is important here, right? Which is to say, the word is, for this question, word is defined as a sequence of alphabet characters. Now, I would say that in like 70% of the cases, the answer that is going to come is what I have on the screen, which is that they will count the number of spaces and assume that every time there is a space, it's a new word. But that is not the definition of word that is in the question. This is the definition of word that you found on the first hit on the internet. You just searched for program to count words. The first hit had this code. You copy pasted it here without looking carefully, without realizing that the first hit on the internet is using a different definition of word, and the question is asking for something different. Okay. Another problem is that if the student has managed to write a reasonably correct working program, they still don't think of the errors. They assume that the input is going to be all perfect, and then you just have to write the core logic. But one of the important things, big differences between professional programs and student programs, is the amount of error checking you have to do, the number of causes you have to think of. And that is something also missing, and also companies are looking for carefully. And this is a third big problem, which is that students usually they get the program to somehow work on their computer, and then they submit it, and the system doesn't accept the program. Okay, at this point, there are two approaches. I mean, one is to try to figure out why does your program work on your computer but does not. The other approach is to say, oh, well, it works on my computer, the system is wrong, and then start complaining to the TPO or to the company invigilator or something like that, right? Again, think of real life. I mean, if you're sitting in a company and you write software and it works on your computer and you send it to the customer or you upload it to the Android Play Store, and then when people try to use it, it doesn't work on their computer. You can't tell them that it works on my computer, so now it's your problem, right? You fix it. I mean, the thing a programmer is supposed to that are going to work on all computers, right? Especially if you're writing Java code, right? The whole thing about Java is supposed to be, write once and run anywhere or whatever it is. I mean, you need to know what kind of mistakes result in a program that works on your computer but doesn't work on other computers. This usually involves things like uninitialized variables or not using standard standard language constructs and using non-standard things. So one very common problem is that, you have learned Turbo C in your college, so you only know about Turbo C and you use things which only work on Turbo C but which are not part of, and so it doesn't work anywhere else. So this is the kind of problem you need to be able to fix. Okay, I'm going to skip some of these. Another thing is really bad variable names, right? Because let's look at this example. L1 equal to something, L2 equal to something, A equal to something, X equal to something, K equal to L, I equal to something, M equal to something, J, right? By now, if I'm reading this code, I have no idea what I is and J is and K is, and this code is impossible to read. I mean, your variables and functions should have meaningful names so that it should seem like pseudocode. I mean, just reading the code, I should understand what is going on. Okay. What else? Another problem is that you just write all the code in just one long function, and that is...
Naveen, your voice is breaking. Can you just check the audio?
Yeah, just a minute. Okay, Shekhar, is this better? Shekhar?
Still not.
Just a minute.
Yeah, this is better.
Hold on. How about this, Shekhar? Is this okay? Shekhar?
Go ahead.
This is okay? All right. Yeah. Sorry about that, everyone.
Okay.
Yeah. So the thing is that, writing the entire program, I mean, I just took the screenshot of code. It just goes on and on and on, and I don't know how many for loops are there and how many if conditions are there, and everything has been stuffed into one function. You have been taught, especially in your software engineering courses and other courses, that your code should be modular, break it up into functions. If you're using Java, then there should be classes and methods and so on. And not writing that is a sign of a bad program. Okay, so that was about programs. Let me move on to common problems in queries, right? Now, one of the things is that pretty much like 70-80% of the code in modern software industry is based on, the data is stored in databases. It is not stored in files. It is not, coming from users. It is stored in a database. And ultimately, most programs have to database. So somewhere or the other, there is querying of the database going on. So some understanding of databases and queries is important for all students and is part of most or many campus interviews, right? And the problem is that all the problems that I talked about in programming, not reading the question carefully, not knowing the syntax, all of those exist, but there are some special additional problems in SQL, and which is that, people don't know SQL syntax properly. Okay, so there are problems with the syntax. People don't know how to use SQL. They know vaguely what SQL is, but they have rarely, it appears that they haven't actually used too much SQL on a real database, and so they keep making syntax errors, right? So here is one example where it doesn't, this is not SQL, right? What is in group by department ID is not valid SQL at all, for example. And this kind of error is very common. Another common thing is that if in the question I gave you 4 tables, right? Then without looking at the question, people join in all 4 tables and then see what to do with it, right? And that's not right. Every join in SQL is very expensive. One of the things you have to know about database, the reason we used a database is because the amount of data is huge. And if you don't write the right kind of query, the performance can go down from a fraction of a second to 5 minutes and cause serious problems, right? So unnecessary joins is a serious problem. Another problem that students have is that they are sort of comfortable with join queries, but they are not they are comfortable with simple group by queries and aggregates. But when you start combining them and do something a little more complicated, they get totally lost. And because they have never practiced any of those, they end up with either very complicated queries or queries that don't work at all. Similarly, focus in teaching is all on doing joins and queries. But one of the important things needed in industry is actual updates and, slightly complicated updates. And that's something that most people have never actually worried about other than simple one-liners. Okay. Similarly, subqueries. People get completely confused when there is a query that requires you to use subqueries. Okay. Now, all of this is not very difficult. SQL is much, much simpler than the Java and the C++ that you are learning. The problem is that students never actually focus on this. They don't pay much attention to this. That is why they are not able to do this when the time comes, right? One important example is that if I tell you that find me all departments where average salary is greater than 50,000, right? Now, one of the important things you have to realize is that in the where clause, I cannot write AVG, average of salary is greater than 50,000 because aggregates are not allowed in the where clause, right? So if you want to have a condition on an aggregate, you can't do it in the where clause. You have to do it in a clause called having, which many students have never heard of. Okay. And so I'm going to skip some of these things. Another problem is just unnecessarily putting a order by clause at the end of the query. Now you should again know that an order by is a very, very expensive operation in a database, especially if the output is going to be large. And if you put an unnecessary order performance, right? So not thinking about performance is a big problem among students. Now, going on to other issues. So that is the programming and the SQL. Now, just generally about